Cortical mapping of the sensorimotor area is the critical first step in various applications, including resection brain surgery and control of prosthetics.
Usually, during surgery, the sensorimotor area is defined using the phase reversal of the median nerve-induced somatosensory evoked potential, or SSEP. This approach relies on the subjective interpretation of the phase reversal amplitude that is recorded with strip electrodes. When there is unsolvable doubt, direct cortical stimulation is employed, which is time-consuming and triggers seizures from prolonged usage. Using customized, high-density grids, we recorded intraoperative ECOG from the sensorimotor cortices of 8 patients. We stimulated the median nerve of each patient while they were anesthetized and after they were awake at a low frequency. We recorded the neural data and the EMG to capture the stimulation pulses, which appeared in the form of sharp spikes. Neural data was then processed in real time using g.tec high-speed libraries and DSP block sets in MATLAB Simulink. This generated overlapping plots of the SSEPs and gamma power. We then converted the plots to a heat map that was displayed on the OR screen for subjective interpretation by the neurosurgeon. Here is an illustration for the SSEP spatial temporal features as a heat map. And here it is for the spatial spectral profiles as a heat map in real time.
Clinical intraoperative systems translate the activity of the brain to monitor the consciousness of subjects following anesthesia. While background cortical activity has been used widely to differentiate asleep and awake states, we hypothesize that spectral features of SSEPs can serve as a valuable tool for assessing consciousness.
We assessed the spectral components of the SSEPs with Stockwell transform. Interestingly, we observed late gamma activities that were suppressed in the anesthetized state and increased in the awake state. We also evaluated the peak latencies between the conventional N20, P20, and subsequent P30, N35. While we did not see a significant difference in M1, the IPL showed a significant difference in S1 between anesthetized and awake states.
The SSEPs can not only be used to map the sensorimotor area in real time and in a short time in the OR, but it can be used to assess the level of consciousness.